Space is vast, mysterious, and filled with wonders, but it's also home to potential dangers. Asteroids, rocky remnants from the dawn of our solar system, silently drift through the cosmos, and some of them come uncomfortably close to Earth. These near-Earth objects, or NEOs, could pose a catastrophic threat if they collide with our planet. But here's the chilling reality. Many of these asteroids remain unseen, hidden by the very orbit of Earth itself. Today, we're diving into the science of why these cosmic threats are so hard to spot and what we're doing to uncover them before it's too late. Let's start with the basics. Asteroids are chunks of rock and metal, ranging from a few meters to hundreds of kilometers in size, orbiting the Sun. Most reside in the asteroid belt between Mars and Jupiter, but some have orbits that bring them near Earth. These near-Earth asteroids are the ones we worry about. A collision with even a moderately sized asteroid, say, a few hundred meters across, could release energy equivalent to millions of nuclear bombs, leveling cities or triggering global climate shifts. The dinosaur-killing impact 66 million years ago, caused by an asteroid roughly 10 kilometers wide, is a stark reminder of what's at stake. So why are these asteroids so hard to detect? The answer lies in Earth's orbit and the way we observe the sky. Imagine Earth as a car driving around the Sun on a circular track. We're constantly moving and our perspective of the surrounding space changes with that motion. Most of our asteroid-hunting telescopes are ground-based, scanning the night sky for faint, moving objects. But there's a catch. Many asteroids are hidden in regions of space that are difficult or impossible to observe from our vantage point. One major blind spot is the direction of the Sun. Asteroids that approach Earth from the Sun's side are often lost in its glare. Picture trying to spot a dim, distant object while looking toward a bright flashlight. It's nearly impossible. These dayside asteroids, as astronomers call them, can sneak up on us because our telescopes can't see them against the Sun's overwhelming light. In fact, some of the most dangerous asteroids, like the one that exploded over Chelyabinsk, Russia in 2013, came from this direction. That 20-meter-wide rock injured over 1,000 people and shattered windows across a city, and we didn't see it coming. Another challenge is the geometry of orbits. Many near-Earth asteroids have paths that keep them in regions where they're either too far from Earth to detect or aligned in ways that make them invisible. For example, some asteroids travel in orbits that are nearly identical to Earth's, trailing or leading us around the Sun. These co-orbital asteroids are tough to spot because they stay in roughly the same position relative to us, blending into the background of stars. Others, like the so-called Atira asteroids, have orbits entirely inside Earth's, making them almost always obscured by sunlight. Then there's the issue of size and speed. Smaller asteroids, those under 140 meters, are incredibly hard to detect because they reflect so little light. Yet these smaller rocks can still cause significant damage, and asteroids don't move slowly. Some zip through space at tens of thousands of kilometers per hour, making them fleeting targets for our telescopes. By the time we spot one, it might already be too close for comfort. So, how do we find these hidden threats? Astronomers rely on a combination of powerful telescopes, advanced algorithms, and international collaboration. Projects like NASA's Near-Earth Object Observations Program and the Pan-STARRS survey scan the skies nightly, cataloging thousands of asteroids. Space-based telescopes like the upcoming NEO Surveyor mission are game-changers. Unlike ground-based scopes, NEO Surveyor will orbit the Sun and use infrared light to detect asteroids that are invisible in visible light, especially those lurking near the Sun. Infrared is key because asteroids emit heat, which can be picked up even when they're too faint to see otherwise. But finding asteroids is only half the battle. We also need to track their orbits with precision. This is where supercomputers and orbital mechanics come in. By observing an asteroid multiple times, scientists can calculate its trajectory and predict whether it might cross Earth's path years or even centuries from now. The Torino scale, a system for rating asteroid impact risks, helps prioritize which objects need closer monitoring. So far, no known asteroid poses an immediate threat, but the catalog is far from complete. What happens if we find a dangerous asteroid headed our way? This is where planetary defense kicks in. NASA and other space agencies are developing strategies to deflect or destroy incoming asteroids. One approach, tested in 2022 with the DART mission, involves slamming a spacecraft into an asteroid to nudge its orbit. Other ideas include using lasers to vaporize parts of an asteroid's surface, creating a thrust to alter its path, or even detonating a nuclear device as a last resort. These methods sound like science fiction, but they're grounded in real physics and engineering. The stakes couldn't be higher. While the odds of a catastrophic impact in our lifetime are low, the consequences are so severe that we can't afford to ignore the risk. Every year we discover thousands of new near-Earth asteroids, and each one adds to our understanding of the cosmic neighborhood. But the unseen ones, those hiding in the sun's glare or trailing in Earth's orbital shadow, remind us that space is unpredictable. The good news? We're getting better at this. New telescopes, better algorithms, and global cooperation are shrinking our blind spots. Citizen scientists are even pitching in, analyzing telescope data to spot asteroids that automated systems might miss. The more we learn, the safer we become. So the next time you gaze at the stars, remember, our planet is part of a dynamic, ever-changing cosmic dance. Hidden among the beauty of the night sky are threats we're only beginning to uncover. By understanding how Earth's orbit hides asteroids, we're taking the first steps to protect our world from the unseen dangers of the cosmos. Stay curious and keep looking up.